Thank you for inviting me to talk here. Virginia is part of the Prof Trust, and she was one of my PhD students many years ago. Well, not many years ago, a few years ago. And it was great to see Helen's talk. Helen I taught when she was an undergraduate at University of Auckland, and when she talks about being in the field for 20 years, I suddenly realised, oh my goodness, okay, so I won't tell you how long I've been doing this. But I've always been interested in birdsong, and I went overseas. I was born in Henderson in Auckland. I went overseas to do my PhD to the US, and I realised during that time that all of the models all the things we see in books, all the examples we see, are all of these North American, European species. And in New Zealand, when I came back to New Zealand to start my own career here, first at University of Auckland and then at Massey, I thought, our species do things a little bit differently. We don't have migration, we don't have birdsong in the same way that the European species do. Many of our birds, males and females, sing. Our birds sing year round. They're not migrating off thousands of kilometres away and then coming back and setting up a territory. And what I wanted to do was to build up information about our native species with the hope that those end up in textbooks that students in North America and Europe can read about. So we're still working on that bit, but anyway, most of it happens though because of the kind of pest and predator control that has been going on in New Zealand for many years. So the example I'm going to use today is Saddleback primarily. I've been working on Saddleback now for, I don't know how many years actually, 15, 20 years. I work on other species as well, and bellbirds are actually my favourite, but I'm going to talk to you about Saddleback today. So in New Zealand, when I first came back to New Zealand after studying overseas, I suddenly was struck by how important these conservation islands were. I mean, at that stage, that's what was going on. And how important, everything in New Zealand was kind of centred around conserving, and it's kind of doing the most we can when the species are so clearly at risk that we're at risk of losing them. But, and so I don't have to tell you much about this. We know that these are the culprits. You guys especially know that these are the culprits. These are the things that are destroying our native fauna and flora. And we know that the other aspect of the risk to New Zealand species is the loss of forest. The loss of our forest that has been going on ever since humans arrived, and then the fragmentation of those forests. And that combination of fragments rather than contiguous forests and these predators and pests that have got into all of these areas means that our native species clearly need help. So why am I talking about song? It seems a bit frivolous to talk about song when we are worried about actually extinctions. But I think the song culture is important because it's part of the social life of the species that we're trying to preserve and reinstate in areas. And so when we think about functioning ecosystems, we can also think about functioning societies of these species that are using those forests. And part of that, especially for the songbirds that learn this song, is the culture of song. And so what this is kind of what you notice the most when you come back to New Zealand after being away a long time. Now this is what we all would like in our backyards if we can make this work. How's it going? Yeah. Maybe we don't want the really loud bit in our backyard too early in the morning. But this is, when I show this to people overseas in the Northern Hemisphere, I explain to them this is in the middle of winter. These are males, females, juveniles, all singing. They're singing around a food source, and they're singing not just for us, they're singing to communicate with each other. And this was taken on Territory Martini a few years ago. And that's what we want to see all over the place. they doing this? What are they communicating with each other? And so what are the dynamics around that song that is going on? Now, so bellbirds I could talk about for a whole another hour, but today I'm going to focus on Saddleback because that's where we started with this group. Now, many of you will know the history of Saddleback. It's a really important one for translocations because they really were the first birds that were successfully translocated. So the history of those conservation actions, of those translocations, when I first was looking at it, I realized that if I was going to design an experiment to try and figure out what's going on with song and song culture and how songs might change, I would design it the way we have done these translocations of Saddleback. And so I wrote a master's grant, to try and get some funding so I could go and do just that. And it was successful, and that was the first one that we did. And we also then wanted to follow up with, I'm going to talk about how we then go on further from just understanding the basics, to then go on and design experiments and experimentally test some of the ideas that come out of understanding song culture. So I'll come back to why it matters in a moment. Now this work, when I first got this funding, many of you will know Kevin Parker. He is very well known around New Zealand now as Mr. Translocation. He did his master's with me on Bird, and I got this funding to work on Saddleback and had to work really hard to convince him that he wanted to work on sound, that he wanted to work on song. He just wanted to save everything, but he decided to take up a PhD with me and work on sound analysis. He hated every minute of sitting in front of that computer and analysing all of that data. It was very clear, but he did a fantastic job. And so I'm going to start by giving you the background from the work that he did. So we have a natural system. Even though these translocations have taken place, it's still a natural system. The birds are in these islands once you get them there. They're on these islands, in these locations, and they are just left alone to do their thing. The nice thing about translocations as an experiment in a natural system is that we know the age and the sex and the number of birds that get translocated. So when birds are moving dispersing into a new area without translocation, they're doing it naturally, as the bellbirds did, moving to Tāwhiranui from Little Barrier. We don't know that. We don't know how many there were exactly. We don't know what sex ratio it was, and we don't know their age. So these translocations give us that extra layer of information, which enables us to analyse that data. And with Saddleback, when you put them on an island, they stay there. They can't leave. So that means we have these nice closed populations. So from my point of view, it was a great thing to have. And then for Saddleback, males only sing. So that also makes it a little bit simpler. Bellbirds are a lot more complicated because females sing as well. And males and females have their own song culture. What was known from Peter Jenkins' early work was that Saddleback rapidly changed their songs. And so that was known. But we can get some insights from these translocations about what the effect of isolation might have on those song cultures. So that's what we did. So quick background for Saddleback. This is more for people that aren't aware of Saddleback, which you guys I'm sure are. They're an old family of birds to New Zealand, the waterbirds. They were widespread before European settlement. They don't fly well, they spend a lot of time on the ground, they love forests, they're very long-lived actually, and they're territorial. Wonderful species to work on because they kind of ignore you when you're there, so you can get close for recording. They stay on their territory all of the time, and they're not super aggressive with each other, which is really, that one I don't understand why, but I'm going to work on that. Sons disperse, which is in most songbirds, females are the ones that disperse. In Saddleback, sons disperse, and it seems that they learn the songs in the neighbourhood that they move to. And in 1903, they were stuck on one single island. So they have got low genetic diversity, and they were reduced to a single island population. Then in 1964, it was realised that having all your eggs in one basket, obviously, is not a good thing. And so the first translocations happened. So this is Hen Island. We're all well aware of Hen Island, which is not very far from here. It's a tough island to work on. We've spent several field trips there collecting bird sound recordings. It is really hard work, but fantastic, and I've been very privileged to get to be out there. The first translocation was done in 1964, and you can see in this picture here, you can see the small island off to the side there. Whakapōkī, this is my photograph from the top of Hen. That was the first translocation from Hen to there to Whakapōkī, really as a bit of a trial to see if it would work, and it did. It worked well. And Saddleback are great for translocations. Almost all of the translocations that have been done, and these are not all of them, there's even more now, almost all of them have been successful. If you remove the predators from an area, Saddleback will thrive. They eat almost anything. They have, they're pretty easygoing, but they cannot cope with rats themselves. So the only ones that have failed, these 5 here that have failed, primarily because of predator reinvasions into areas, or not having predators low enough. So they do well. Now this setup gave us the opportunity, when Kevin started this PhD, this was our experimental setup. So you can see we've got Hen Island. What the translocation process or history for Saddleback is that from Hen, they were first translocated to Whakapōkī, then to Red Mercury and to Kuvia. And you can see the year that this was done, and in brackets the number of birds that were translocated. And then what happened after this is, if you look at the Kuvia population, they let the population grow, and it grows rapidly. In fact, Saddleback will start breeding at about 8 months of age. So they're really fast, and they just keep going. And in fact, on some of these islands, they're having 3 clutches a year, and quite large clutches. So they fill these islands up quite quickly. From Kuvia, another series of translocations were done. Now, all of these are pretty much single source to a new location. So Kuvia to Stanley, to Tiri, to Little Barrier, to Motahora, and then the third level, Kapiti, Makoia, Motuihi. So what's happening here is you've got a subset of animals, a small number of animals being taken essentially randomly from a population, from a large population, and moved to a new site and left to breed and the population grow. So obviously from a sound point, or from a song point of view, you're not capturing all of the diversity that is at Hen. It's not moving, you're taking a subsample, a random sample. It's like if I just grab a small group of you and send you off somewhere and isolate into an isolated site, I'm not going to capture the entire diversity of this whole population. So what it means is these islands change, and then in addition, they are inventing new songs and new song types. So you like to have divergence of the song in the same way that you would have genetic divergence over time. Now just to give you some idea of the differences between the song, here is one from Hen. Squeaky wheelbarrow song. Now this is one, it's called a male rhythmic song, because you can see there's this pattern of it. Often they sound like car engines trying to start. And then here's one from Motahora. You can see it's quite different. This is one we hear a little bit more. Again, it's like a car engine, and it's got this repeated mode. So they are very, very different. And this is how we look at sound. So these are spectrograms. Now I won't repeat those songs again, they're the same songs I just played in that. But what you can see along the bottom here is time, and then up the side we have frequency or pitch. So from low frequency up to high frequency. And then the colour, the depth of colour, So in these spectrograms here, there's lots of information that we can pull out. And it's a way of actually quantifying the sound. So we might take, in fact, we take up to 40 or 50 different spectral measures on these things. And that enables us to actually physically compare, quantitatively compare different song types and cluster and sort them out. So this is the graph that just about made Kevin cry because it represents about, I don't know how many hours of island visits and recordings, over 5,000 recordings of Saddleback, which are hard won, getting to these islands and getting these recordings. You can imagine the bird doesn't just sing when you stick a microphone in front of it, the wind doesn't stop, it doesn't stop raining, a whole lot of things. Anyway, I'm not going to bore you too much with the statistics involved, but basically, because we've taken a whole lot of measures on each song, and then we've got a whole lot of songs from these different locations, we use an ordination technique, in this case non-metric multidimensional scaling, which just crunches down all that numbers and maximizes the differences between our data points so that we can visualize how different these things are. So if we look at hen, the black triangle there, and we compare it to, if we look down there, copper mine, those are the most different. So where they are, points that are close together are more similar. And what we see, which was pretty exciting for us, and hopefully you'll enjoy the enthusiasm for this as well, but is we basically have these lineages. So straight away, if you look at hen, red mercury, and wharapuki, straight away you can see just by this sampling that we have done, that these populations have diverged. And we end up with, if we look at the yellow dots and we look at the blue dots, we've got different lineages. So basically there's been rapid evolutionary, cultural evolution change in these populations. So this was pretty, we thought was pretty interesting. But we had to ask the question, does it matter? Does it make any difference to the birds? Do they care at all? And so the first thing we did was to do some playback experiments. So we did a new translocation, and we took Saddleback to Motuihi Island from Terry. And then we let them settle down, do their thing, population got a little bit bigger, and then we went and played back. So we do playbacks on territories, and we played back to the Motuihi birds' local song, not their neighbours, but local song from the island. We played back Kuvia song, we played back Hen Island song, and then we had a control, which were grey warblers. And grey warblers do not like grey warblers. They really came in, and it's sad that we more them, but we had trouble with grey warblers attacking our speakers. Feisty things. But what you can see here, and again we used a number of measures, but what you can see here, this is a measure of really of intensity of response. And what we found was they responded most strongly to local song, and much less strongly, significantly less, to ancestral song, to Kuvia and to Hen. So they really were noticing local song and ignoring these other stranger Saddleback songs, if you like. But again, does it really matter? Oops, sorry. Too far. And so the only way to really test it is to do translocations that have multiple sources going to one site. That's the only way to really know that it makes a difference. So Kevin and others convinced the Department of Conservation to do a number of these multi-source translocations to not only to maximize genetic diversity, but to maximize cultural diversity and to be able to test to see whether it makes any difference. So there were a number of these that were done, and I'm going to talk about Shakespeare primarily, but we also have some information about Tāwhānui. And you can see for Tāwhānui, we managed to get translocations from 3 different sources, which represented the different lineages that first came out of Hen. And for Shakespeare, the birds came from Tawharanui and from Territory Martini, which represented two of the lineages. So these colours represent the lineages. So, what were the results? Well, it got complicated, and it got complicated because of predators. So, I had a new student, Kyle Sutherland, a master's student from Canada, and he, everything looked great. It was going to be a really nice setup where we can go back after a couple of years following the translocation and see what is sung, where the birds are. But predator invasions happened at both Tawharanui and Shakespeare, and that kind of interfered with what we had planned on doing. First of all, the rats had got into Tawharanui, which meant that Kyle focused a little bit more on Shakespeare. So I'm going to talk about the Shakespeare results now. I'm not sure how I'm doing time, but I'll keep going. Right. So the questions we asked are relatively simple. Has song diversity increased, decreased, or remained stable? So when you've moved these birds, you might lose some birds. You don't know what they will sing up when they get there. So just ask that question. Then, does assortative mating occur based on their source location? This just means, are females choosing males from the location that they came from? So that would mean that they didn't like the songs of these strange birds. And so it might be a problem if you've got them just separating and not actually mixing. And how does song type sharing relate to the distances? When they settle, when the birds settle in these new locations, how does the song types change? Do they settle all together? One kind of source and one kind of song type in one area and one in another? And then finally, what song types are learnt and sung by those first generation birds? And that was probably the most interesting thing we looked at. Now, the methods are pretty straightforward. These birds, when they were translocated, all have colour band combinations, unique colour band combinations, so we know who they are, where they are. The first generation males, this was 2 years following translocation. First generation males were all unbanded. We didn't get our permit to be able to ban these birds. But we knew anything unbanded was a first generation male because there hadn't been that next breeding season yet. So that made it straightforward. We had a target. It's actually harder to get all these recordings than you would think. We had a target of at least 5 good song recordings for each male. Okay, so, and then and then the final thing was the analysis we did with some new software that we developed ourselves called Cohen. I'm not going to go into depth with that, but again, it's a multivariate analysis, and these are what the various spectrograms look like, and I just highlighted here the repeated unit that we measure. So that car engine starting repeat that just happens, and that's the thing we compared. So we're comparing the same thing across different males. Now, all of this stuff requires coordination techniques. So this is another one, another non-metric multi-dimensional scaling technique. And again, what it does is it separates points based on how different they are. And what you're looking at here are, of the 321 recordings that Kyle managed to get, there were 20 different song types. So here we looked at what song types existed, and you can see they kind of separate out quite nicely in this space, and we use a clustering technique to be able to show that these clusters are different. So we named them all with these very imaginative numbers, but the most exciting part was that those 5 that I've indicated with arrows there had not been found anywhere else. These were completely novel song types. So they weren't found on Tawharanui, and they weren't found on Tiri. They were new to Shakespeare. So that was pretty exciting, and they were all done by the first generation males. And this is where they settled. Now, these things never go exactly as you would experimentally design them. So there were more tiri birds than tāwhānui birds caught. The primary thing, of course, was that we had successful translocation and able to catch the birds that we needed. And the tāwhānui birds, there were fewer of those because there had been an incursion of predators and a reduction of that population. So they weren't able to take as many as they'd like. The other thing to note here are these green unknown. So Kyle did his very best to get everything, but these green birds set up territories in the defence land, Navy defence land, in the ammunition testing area. So very, very frustrating that he wasn't able to get in there when he needed. He did get in there a couple of times, but the birds weren't singing when he was there. So we're pretty sure that they are tāwhānui birds because we could account for almost everybody else, but we weren't able to get the birds. And what you can see then is you've got the tāwhānui birds are kind of settled in that top northeast corner, and the other birds have scattered around. I haven't put where the forest patches are in, but they kind of go across all of the patches there. And then the red, are where the young birds settled. And if we take a look at the diversity here of the song types, what we can see is that pretty much everything is represented, and that grey bar at the top there are all these novel songs. So this is pretty exciting that there are these new songs that are specific to Shakespeare. So the conclusions from that are that we actually managed to have higher song diversity by having multiple sources, which was really nice. Sortative mating did kind of occur. I think I forgot to mention that one, but 14 of the 25 birds pairs were from the same source, but there was a bias because we had more tiri birds than taff birds, but there was still some mixing. So there would be mixing, which is nice. We did have these kind of cultural neighbourhoods that seemed to be forming, but we need to follow that for longer to be sure about how they would work. The first generation males were the most interesting though. So when we looked at the songs that they were singing, so like Saddleback can sing more than one song type. So these first generation males were not only singing, were only singing one of the ancestral song types, and then a novel song. So we didn't have any of the first generation males that sang songs from both. So they weren't learning from both of the ancestral population, the ancestral males. And the new song types, as I said, that's really interesting. Now, if we think about what the aims of this translocation were, and that is to maximize genetic diversity and maximize cultural diversity, so it's a success. So within 2 years, we know that there is some genetic mixing because not all of the pairs were they were not all paired with someone from the island they came from. And then we've got these new songs arising, as well as the ancestral songs stay. But there's a very big but with this. Predators got in to Shakespeare. Not long after, well, the second part of the study, Kyle was devastated by this. 80% of the Saddleback at Shakespeare are gone. Were gone. All of those new song types are gone. All of those first generation things are gone. And so it really, really brings home how crucial predator control is, and how important it is to have it ongoing, and how important it is to realise that for some species like Saddleback, no number of rats in an area is going to be safe for them. So it's we're pretty upset about this, but I have a new master's student now, and we're going to be going back and looking at Shakespeare and at tāwhānui, and taking a look at how the population is recovering. And then the final thing I wanted to mention is this: I have a new project, a big project, that is going to look at fragmentation and song learning, social networks of 3 different species, so of tīeke, of the bellbird and tui. All of them have slightly different social networks. All of them will respond to fragmentation of forest differently, and all of them may learn their song in different ways. So in order to get this latest Marsden, I have to promise them everything. But I have a really good group of students that are just starting. In fact, one of them has just arrived in the country the day before me coming back. So lots of people to acknowledge these big projects take big teams going. We have teams of 4 or 5 people going out to islands and recording. It's fantastic fun, it's hard work, but I hope that you find that it is interesting because, in fact, it's what we want as a result of controlling those predators. We kind of really want to get our bird song going again.